Hello and welcome to Windows Analysis. Today, we're pulling back the curtain on that secret world inside your PC, that little bit of magic that happens in the seconds right before you ever see the Windows logo pop up. Here at Windows Analysis, we explore the Windows universe, performance, hidden settings, history, hacks, and updates. If you like understanding your system, stay tuned. So let's just ask the big question. What is actually going on in those first few critical seconds after you press the power button? Because let me tell you, before your operating system can even think about taking over, a whole lot of prep work has to happen first, and it all begins with something called firmware. The easiest way to think about firmware is that it's the official wake-up call for your PC's hardware. It's the super low-level software that lives right on a chip on your motherboard, and its very first job is to run the post or power-on self-test. Basically, a quick check to make sure your memory and processor are awake and ready for work. Once it gets the all clear, it hands things off to Windows.
For like 40 years, the king of this whole process was BIOS. I mean, it was the old, reliable system that booted up pretty much every computer on the planet. But as hardware got more and more advanced, this old guard, well, it started to really show its age.
Now, for some of you, this screen is gonna be a real blast from the past. The classic blue and gray text, keyboard only, no mouse in sight. The whole process was just linear. BIOS would check one piece of hardware, then the next, then the next. It got the job done, sure, but it was a massive bottleneck. It was just plain slow. Now, BIOS wasn't working alone. It had a partner in crime, the MBR, or Master Boot Record. This is a tiny, tiny section right at the beginning of your hard drive, and it holds the map that tells the BIOS where to find Windows. The big problem, though, all of that super critical info was in one single spot. If that one little piece of data got corrupted, well, your whole system was in a world of hurt.
And this is where we really started hitting some hard limits. MBR could only handle hard drives up to 2.2 terabytes. So if you bought a shiny new 4 terabyte drive, anything over that 2.2 mark was just gone, wasted space. As if that wasn't bad enough, you could only have 4 primary partitions on a disk. It was just so limiting for modern computing.
So with all these problems piling up, it was clearly time for a major upgrade. And that brings us to the modern era, UEFI and its partner, GPT. These were designed from the ground up to just completely blow past all those old limitations. And the difference? Well, it's night and day. Right off the bat with UEFI, we got these sleek graphical interfaces you can actually use a mouse in. But the real revolution, the thing that changed everything, wasn't just how it looked. The secret sauce is that UEFI can initialize hardware in parallel, all at the same time. This is the key to everything. And the result of that parallel magic? Speed. We're talking dramatically faster boot times. The difference is just huge. Like we just said, while BIOS was checking things one by one, UEFI basically yells, "Go!" to all the hardware at once. Your system is just ready in a fraction of the time. It's awesome. And of course, UEFI needed a new partner. That's where GPT comes in, the GUI partition table. So remember that 2.2 terabyte limit? GPT raises that to a theoretical 9.4 zettabytes. I mean, that's a number so big, it's hard to even wrap your head around. And we go from 4 partitions up to 128. And crucially, GPT keeps a backup copy of its data. So if the main one gets corrupted, it can be recovered. It's just so much more robust. But you know what? Faster boot times and massive storage, that's all great. But it's not the real reason we made the switch. The number one, most important reason that UEFI is mandatory on modern systems is security. And this is where it gets really, really cool. The star of the security show is a feature called Secure Boot. And I absolutely love this analogy. Think of it like a bouncer at a really exclusive nightclub. Before any software is allowed to run during boot, UEFI checks its ID, its digital signature. If it's not signed by a trusted source, like Microsoft, it's not on the list. It's not getting in. Simple as that. And why does that matter so much? Because it stops some of the nastiest types of malware out there. Things like rootkits dead in their tracks. It slams the doors shut before they even get a chance to load, way before Windows ever starts up. This whole process creates something called a chain of trust, and it's super logical when you think about it. The firmware checks the bootloader, then the bootloader checks the main Windows kernel, and once Windows is running, it checks all of its own drivers. Each link in the chain vouches for the next, making it incredibly difficult for anything malicious to sneak in. So, if there's one thing you take away from this, let it be this. UEFI is not just about a faster boot. It is the absolute bedrock, the foundation of all modern Windows security. So many of the advanced security features in Windows 11 would be flat out impossible without the secure platform that UEFI and Secure Boot provide. Okay, that's a lot of tech talk, but what does it all actually mean for your computer? How does this affect you day to day? Let's get into some practical takeaways you really need to know. All right, a few key things. First, Windows 11 requires UEFI, Secure Boot, and another thing called a TPM 2.0 chip. There's no way around it. It's mandatory. Also, if you like to dual boot with Linux, for instance, everything has to be installed in UEFI mode. And a word of warning, converting an old MBR disk to GPT isn't always straightforward. Finally, and this is a big one, a lot of new PCs ship with that TPM security chip turned off by default. You often have to go into the UEFI settings yourself to enable it. And all of this really leads us to one final important question you should ask yourself. Your computer has all this incredible security technology built right in, but is it actually configured to use it? Is it living up to its full potential? And that's our deep dive for today. If you found this useful, do us a favor and subscribe, leave a like, and drop us a comment below. Enjoy tinkering and see you in the next Windows Analysis Explainer.